Let's do one more example. Werner Brandis, a usability engineer for toy manufacturer Playtronics, surveyed video game players about which of two video game controller designs they preferred, controller A or controller B. The current controller being sold by Playtronics is controller A, but the company will make a design change to controller B if fewer than 30% prefer controller A. Of a sample of 320 users, 88 prefer controller A. So let's draw conclusions about this with 99% confidence. Okay, so we're talking about if fewer than 30% prefer controller A. Fewer than, that implies not equality, okay? There's no equality statement in fewer than. Fewer than is just less than. So our hypothesis statements here would be that P, our alternative hypothesis, is that P is fewer than 30%, or fewer than 0.3, okay? Percentage was 30%, proportion fewer than 0.3, okay? The equality statement must be in the null and it must be contradictory to this fewer than statement. So the null hypothesis is that P is greater than or equal to 0.3, okay? And we went out and collected a sample of size n equals 320, and we counted the number of people who preferred controller A. And that was 88, okay? And we can calculate the p hat, the sample proportion of those who prefer controller A from the sample, and that is 88 over 320, which is 0.275. Again, we want to draw conclusions with 99% confidence. So alpha is 0.01 in this case. Okay? So we've got our sample evidence, and we want to draw conclusions about controller A and the preference of controller A. If fewer than 30% prefer controller A, then we'll make a change. And this is our estimate for the proportion from the sample that prefer controller A. So let's use the critical value approach first. Here is our Z distribution. We want a lower tail test, and we want 0.01 to be in that lower tail, okay? And if we go look up for value of Z, what the critical value would be here, that is negative 2.33, okay? So our critical value, beyond which lies our rejection region, is at negative 2.33. So now let's calculate our test statistic. That's how different is p hat from the hypothesized value in standard deviation units. Okay? How different is 0.275 from the hypothesized value, 0.3, in standard deviation units? 0.275, 1 minus 0.275 over n, which is 320. Okay, so if we work this out, this is just arithmetic, we should get that the test statistic is something like negative 0.976. Okay, negative 0.976. Okay, that value lies right about here, negative 0.976. Lies in the non-rejection region. We would not reject the null and conclude that the proportion of video gamesters who prefer controller A is greater than or equal to 0.3. There's no evidence that suggests that, or there's not enough evidence that suggests that this proportion is actually smaller than 0.3, given our sample size and our variability, okay, and our level of confidence. We want to draw conclusions with a quite large amount of confidence. Okay, we want to be super convinced that this sample proportion is smaller than 0.3. That's why we have such a very small value in this lower tail. Okay, we want to be super convinced of this result. Okay, so that's the critical value approach. We fail to reject the null and conclude that the proportion is no smaller than 0.3. Let's use the p-value approach. Okay, we've got our test statistic, and let's just find out what the area in the tail below that test statistic is. So here's the Z distribution. Here is our value on the z-axis, negative 0.976, and we want the area in the lower tail to be entirely our p-value. Okay? But we can't look up 3 decimal places in the z lookup table. We can only look up 2. So we'll have to round that up to negative 0.98. Okay? So if we go look up the value of 0.98, so if we go look that up in the table, we're going to get something like this. Okay? Between 0 and 0.98 on the z-axis, this area in the lookup table would be 0.3365. That must mean this area is 0.5 minus that, which is 0.1635. Okay? That p-value, this area right here, this area right here are the same. So our p-value is 0.1635. Okay? That's a pretty large p-value. That's larger than any alpha that we would really choose. It's certainly greater than alpha. So p-value greater than alpha. Therefore, we do not reject the null. Okay? Very large p-value, much larger than this 0.01, so we don't reject the null. And we conclude that we should not switch away from controller A. No, don't switch to controller B. The proportion was not fewer than 0.3 that preferred A, so we're not going to make our design change. If we did not like rounding up to 0.98, if we really wanted to be specific about this, or even more specific with more decimal places here, we could go use a value from Excel. Okay, so we could go use the norm S inverse function in Excel. Norm S inverse reads in just a value of z, and it gives us the cumulative probability up to that value of z, which is actually describing what we want here. We want the cumulative probability from negative infinity up to this value that we read in, negative 0.976. Okay? If we do that, then we get a value of 0.1645. Okay? A little bit different than this, certainly not enough to change how we're going to draw conclusions, but we could always use this norm S inverse function as opposed to the z table. Just depends on what we have available to us, how many decimal places we want, and so on.